Hello and good morning, students. This is chapter 3, Electrochemistry. This video is on galvanic cell or the voltaic cell. This cell converts chemical energy into electrical energy. They are named in the honor of Italian scientists Galvani and Alexander Volta for their remarkable contribution in the field of electrochemistry. In this cell, spontaneous chemical reactions occur, that is, oxidation at anode and reduction at cathode to produce electricity. Galvanic cells are made of two half cells called anodic half cell and cathodic half cell. Electrodes are connected by electrically conducting wires and the two solutions are connected by a salt bridge. Now the Daniell cell. Daniell cell is an example of galvanic cell or voltaic cell. It is made of two half cells are represented below. The first half to the left hand side is zinc solid, zinc sulfate aqueous, where zinc solid is the electrode and zinc sulfate aqueous is electrolytic solution. After the two vertical lines to the right hand side, electrolyte solution is copper sulfate aqueous and the electrode immersed is copper solid. Left side is known as anodic half cell, conventionally represented by negative sign, and the right side is called cathodic half cell, conventionally represented with positive sign. Now here is the pictorial presentation of galvanic cells. Conventionally, galvanic cells contain anodic half to the left hand side and cathodic half to the right hand side. According to the presentation right now you have seen, for Daniell cell, zinc electrode is immersed in its electrolytic solution zinc sulfate. You know children, zinc is more reactive than copper, so the reaction down to the figure you can observe that zinc is losing electron and converting into zinc dipositive ions. So this side is known as anodic half, where oxidation takes place. To the right hand side you can see cupric ion gaining 2 electrons and converting into copper solid. Gain of electron is called reduction. It means this side or this half cell is cathodic half cell. These two half cells are connected by the insulator wire, where a bulb is also glowing in the mid. And also these two half cells are connected through the salt bridge. Let's see in detail. Function of Daniell cell. The first function is oxidation take place at anode and reduction at cathode. Second is electrons flow from anode to cathode in external circuit. Third one is electric current flow from cathode to anode in external circuit. Fourth is chemical energy of redox reaction is converted to electrical energy. Next is zinc rod loses its mass while copper rod gains mass. Next, concentration of zinc ion in solution increases and that of cupric ions in solution decreases. And the last one is solution in both half cells remains electrically neutral. Now, functions of salt bridge. Salt bridge provides an electrical contact between the electrolytic solutions of two half cells, and thereby electrical circuit is completed. Salt bridge prevents liquid junction potential, which means a potential difference which arises when the two electrolyte solutions come in direct contact with each other. It maintains electrical neutrality in both half cells. Now let us study about electrode potential. In anodic half cell, the electrode has tendency to lose electrons. It means it undergoes oxidation. This tendency, called oxidation potential, mixed electrode metal plate negatively charged. In cathodic half cell, the positive ion in the solution tend to deposit on the metal plate by gaining electrons. This tendency is called reduction potential, which makes the electrode metal plate positively charged. Electrode potential is defined as the difference of electrical potential between metal electrode and solution under equilibrium condition. The reactions you can see, the first is M, that is representing metal converting into Mn positive by the loss of electron. In other case, that Mn positive means the cation metal is gaining electron and converting into metal solid. Now standard electrode potential. The potential of an electrode when the concentration of ion is unity. That means 1 molar, with respect to which the electrode is reversible at 25 degrees Celsius and 1 atmospheric pressure. It is called standard electrode potential, which is denoted by E0. So we can write standard reduction potential of an electrode is equals to negative of standard oxidation potential of the same electrode. Now EMF of a galvanic cell. The cell potential or electromotive force of the cell is defined as the potential difference between the electrodes corresponding to an external flow of electrons from anode to the cathode. The standard cell potential or standard EMF of the galvanic cell is defined as the potential difference between the two electrodes when no current is drawn from it. Mathematically, it is given as E0 cell is equals to E0 cathode minus E0 anode. Reference electrode. It is an electrode whose standard reduction potential is arbitrarily taken as 0 or exactly known. Standard hydrogen electrode is also abbreviated as SHE. It is an electrode in which pure and dry hydrogen gas is bubbled around platinized platinum at 1 atmospheric pressure. The platinized platinum should be immersed in 1 molar H plus ionic solution. Look at the figure of standard hydrogen electrode. Here, the platinized platinum wire, which is coated on the platinum foil, is immersed in 1 molar aqueous solution of hydrochloric acid, and hydrogen gas, which is pure, is bubbled exactly at 1 bar pressure. This is SHE or standard hydrogen electrode. Now, applications of standard hydrogen electrode. It is used as primary reference electrode to determine the standard potential of other electrodes. For example, zinc rod is dipped in 1 molar zinc sulfate solution and combined with standard hydrogen electrode with the help of salt bridge to form a cell, and it is represented as this. Again, the left half you are seeing zinc sulfate, and the right hand side we have hydrogen electrode. that is Ch3, where H plus ion 1 molar concentration is present in the hydrogen gas, which is bubbled exactly at 1 atmospheric or 1 bar pressure in support with the inert platinum wire electrode. Now, how calculation of electrode potential of any half cell, for example, magnesium half cell, can be done using standard hydrogen electrode or Sh3. Since we know now that Sh3 electrode potential is arbitrarily taken as 0, so whatever other half cell is connected to this, its electrode potential can be calculated. And this is the setup, children, where you are seeing how the two halves are connected with each other using an insulated conductor wire, where Sh3 or hydrogen electrode is considered as the standard. This way we can calculate the electrode potential of the other half using the same formula you have studied in the previous slide, that is E0 cell is equals to E0 cathode minus E0 anode. I hope you understood about the galvanic cell or the voltaic cell and the other topics which I have included in this video. Thank you very much.